Assalamu alaikum. So today we're going to talk about function. So before we define what is function, we're going to talk about expression. So we're going to define what is expression. From expression, we're going to talk about function. Expression comes from the verb express, which is mean in dictionary represent by sign or symbol. So expression came from verb express, which mean represent by sign or symbol or symbol. So in math we have two types of value. In math there are two types of value. So known value or unknown value. So those are the two types of value you may see in that. For known value, we express them or we represent them either by Arabic digit symbol which mean those symbols 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or we present them as a combination between operator and symbol, or combination. So for the representation with the Arabic digit we call them numbers, but when we combine them combination with the number and symbol. Combination of number and operators. So operators mean addition, subtraction, multiplication, division. So I'm talking about addition, subtraction, multiplication and division. So in that case what we call them? We call them numeric expression. So they're called numeric expression. Numeric expression. So this is the case if we know the value. Either we represent them with symbol, Arabic digit, so in this case we call them number, or if we combine numbers with operator, then we call them numerical expression. For unknown value, either we represent them with alphabet letter, represent them with alphabet letter, any alphabet that you wish, X, Y, A, B, and Z, so we call them variable, or a combination of numbers, alphabet letter, operators. So in that case we call them algebraic expression. So that's the intro for expression. Next, what we can do with the numeric expression. So the only thing we can do with numeric expression is to evaluate. So the only thing we can do with numeric expression is to evaluate. That's it. So we just use all the operation to evaluate. Is to evaluate. In terms of algebraic expression, so there's two things we can do for algebraic expression. Either we simplify them, or what we do, we evaluate them if we know the value of the variable. So either we simplify them if it's possible, or evaluate them if we know the value of the variable. If we know the value of the variable. So that's the two things we can do with algebraic expression. So if numeric expression represents the value of a number, so what about the algebraic expression? In fact, the algebraic expression represents the representation of another variable that we don't know. So if I choose x is my variable, 2x plus 7 is another variable that I don't know. So those are not the same, but this is another new variable, so which is made of what? Of numbers, operator, and the variable that you have here. So which means that this is another variable, so we don't know. So in fact, algebraic expression is a representation of another variable that we don't know, so for an unknown. So that's all. So do we know the name of that unknown? No, we don't know the name. So that's the idea behind. Now, what's the difference between algebraic expression and function? So this is what you're going to see right now. To see the difference between expression and function, so I'm going to use a very simple example. I hope this will work. So I have, let me divide this, so just to show you the idea. Alright, so this is expression, and this is function here. Alright, so let's talk about a sport team. I have a player X and I have a player X. So this player play with the team, so is team player. Here he doesn't play with any team, so we call it what? Free agent. Okay, now if the free agent practice every day to keep in shape, so he practice every day, so whatever input he put, so if I choose X, practice 4 days, so this means he get 2 times 4 plus 7, so it's going to be 15. Does everyone benefit from this 15? No one benefits from this 15. Now, suppose the player play in a team. So the team is defined with this form. If the player put an input of 4, the team get the 15. That means the input affect the team. So the team is my y, and x is the player. So whatever input the player put in the team get the benefit. Here, no one get the benefit. So the difference between the function and the expression is whatever input I put in the variable in the expression, it's just a number. Doesn't have name, it's just a number like 15, 12 or whatever it is. So just a number. So which means this is just a known number. So if I put in, it's become a known number. So it belongs to anything? No, it's just regular number. Here is different. What's the difference here? This team or the y expect an input from the x to get its output. That means y is the output of the input of x. So this is why we sometimes wrote a function in this format, x, y. All we do with this format, x, 2x plus 7, is that you name the y, we name it by the output. So that means the input and the output. But for a function, I cannot name it like this, 4, 15. Why? Because this is not the output of this. It's just a number. That means they're not related. So that's the difference. So always a function has an input and output, but an expression is just a number, either known or no number. If I substitute the x by a value, it's become known numbers. If I don't substitute, the whole thing become unknown numbers. That's it. There's nothing to add, nothing to do with it. But here is different. Just mean the y always expect input to get its output. So in terms of drawing, I can graph by function, but I cannot graph an expression. That's the difference. Why? Because in the graph we have always two things. We have what is my input, and which output I got. So that's the difference again. As you see, the difference between expression and function now. Now let's describe, it's not a definition, this is just to describe what is a function. A function is a variable that can be represented as an expression of one or more other variable. So this is how we describe function. This is not a definition. So function is a variable or that can be represented as an expression of one or more variables. So this is how we can describe a function. It's just a variable that is represented by as an expression of one or more variable. So like for example, like we did previously, to y to x plus 5 as you see here, or we can choose y equal 4x plus 3z. So those are an example of functions. So this is how we can describe it. Function is what is, so we call this is a function, is a variable that can be represented as an expression of one or more variable. And sometimes we represent the function in this format. So f of x to x plus 5, or g of x equal 3x. So here, because we have two variables, so what we do two variable here, because we have 3 and x and z. So x z equal 4x plus 3z. So though this is another way how to represent a function. So there, those are the most useful way that we use in math. Here we write the type of input we use right here. So this is the type of input we use, and most of the time whatever variable we see in our graph tells this is going to be my output. So this is the output. So most of the time, so if you see y equal f of x, or we say y equal f of x, g of x z, it's the same thing. So if you write down f of x or you write down y, is the same thing. So this means the same thing. What's mean? Output. So as you know, based on the description we just say here, function is a variable. And what is a variable? Is a known number. So which means that we can add function, we can subtract function, we can multiply function, and we can divide function. So we can add function, we can subtract function, we can multiply function, and we can divide function. So because the fact that the function is, we describe it as a variable, and we know ahead that variable is unknown number, this means is a type of number. So as long as we can add, subtract, multiply, divide number, so because function is unknown numbers, this means is a type of number that we don't know, so we can add, subtract, multiply, divide function. So to add and subtract, it's like we call it like simplify. So if I have two function, f x equal 4x minus 5 and gx equal x squared minus 3x plus 7. So when we add the function, we combine like terms. When we subtract like terms. When we multiply, we distribute each terms. And when we divide, there is a way how to divide two expression. So for example, if I want to add function, I add like terms. So this is no like terms x squared here, so it's going to stay x squared, and we have 4x minus 3x is 1x, so it's going to be plus x, minus 5 plus 7 is plus 2. So this is when we add. If I want to subtract f of x minus g of x, so I do minus here, so this means there is no x squared, that means there's 0x squared. 0 minus x squared is minus x squared. 4x minus 3x is going to be plus 3x, so it's going to be 7x. Minus 5 minus 7 is going to be minus 12. So this is the one we subtract. If I want to multiply f of x times g of x, so what I do, I multiply 4x minus 5 times x squared minus 3x plus 7. So what I do, each terms of the first expression I distribute it to all the terms of the second one, and the same thing we do with the second terms. So the second terms I distribute to all the terms with the third one. I don't multiply the x with the x and the 5 with the number with the number, and the x with x. No, each terms of the first expression must be distributed to all the terms of the second one. Then we keep moving from left to right. Start from left to right. So you start with the first terms, you distribute to all the terms of the second one, move to the second one, distribute to all the terms, move the third one, and so on. So here in that case, what we'll end up having here, I will have 4x cubed, then I will have minus 12x squared plus 20x minus 5x squared plus 15x minus 35. Then after that, what you do, we combine like terms to simplify the expression. So I will end up having at the end 4x cubed minus 12x minus 5, so it's going to be minus 17x squared. 28 plus 15 is 43 minus 35. So this is my simple form of after simplify of multiplication. For the division, it's the same idea. There is a way how to divide. So we'll do this one just to show you that the same way we deal with numbers, we deal with expression. If I can add numbers, so I can add expression or function. If I can subtract number, I can subtract function. If I can multiply a number, I can multiply function. The same idea. So this is almost like a general introduction to a function, and I hope you got the idea. Thank you, and Assalamu alaikum.